Welcome to MeatsPad, a platform dedicated to sharing breakthrough knowledge that is accessible to the meats industry. On each episode, we will hear from meat specialists and professionals to talk about numerous topics in meat science, including animal welfare, meat production, meat quality, food safety, and so much more.
Hello, meat folks. Welcome back to the MeatsPad podcast. Today, it is a pleasure to have a very well-known, internationally recognized researcher with us today, Dr. Elizabeth Lonergan. How are you?
I'm very well. How are you?
Very good. We were just talking a little before recording that it's kind of interesting how you get to know those authors, and she's done a lot of work on research on pork quality, water holding capacity, and that's really had a lot of impact on my career as far as a PhD student. And this is the first time that I get to know and interact with her, and very happy. How are you, Dr. Bass?
Oh, I'm excited as usual. You know, this is it's always an honor to get a chance to visit with Elizabeth and then get to learn a little bit more about whatever research is going on right now in the state of Iowa. So.
Yeah, so you were telling us you're doing a sabbatical at Colorado State University. Will you tell us a little bit about that?
Yeah, so currently from July to December, we're at Colorado State doing a sabbatical, continuing to kind of expand our techniques in proteomics, but also, learning a bit more about the department and the way different departments work, because both my husband Stephen and I are very involved in teaching in the department as well as research, and so it's good to kind of get a good cross-section of what's happening at another institution. Mm-hmm. So it's been very invigorating.
Yeah, and I'm real excited to get to know more about one of your current research that we were talking about, mineral supplementation. I'm just really looking forward to hearing more about this research and like in beef. So tell us more about what you're doing and yeah.
Sure, yeah. Well, so coming from Iowa, I've typically done a lot of pork research, but fairly recently, I've switched back over to doing more beef research, kind of coming back home. My master's and PhD work was all in beef. So we are working with a nutritionist in our department, Dr. Stephanie Hansen, who focuses on the impact of vitamins and minerals and how that plays a role in increasing muscle growth. She's trying to figure out ways that we can increase the efficiency of the growth of muscle without having to increase inputs, and so to kind of improve the sustainability, if you will, of the beef industry. And she noted that when she started supplementing zinc at super nutritional levels to some of her feedlot steers, she was seeing enhanced muscle growth. And she wanted to take a look at some of the tenderness differences. Maybe was there a palatability difference? So we looked, and in some of her studies, we did see some differences in tenderness, with the advantage being to the zinc-fed steers.
Oh, wow.
So we decided to kind of dive in a little bit deeper on that, and we're currently collaborating on a USDA NIFA grant to dig in a little bit more into the mechanistic side of that. So why is that happening? And is there a way we can maybe make it happen more efficiently? And so one of my current PhD students, Matt Schulte's got a couple of papers here kind of talking about some of that work. And indeed, he's seen that these zinc supplemented steers have, interestingly, an accelerated pH decline, but also an accelerated tenderization. So they reach ultimate tenderness much earlier than their counterparts, than the controls and the others that we had in that particular study. So he's kind of diving in and taking a look at some of the proteomics and metabolomics of those muscles, taking a look at, so is there a difference in the glycolytic pathway? Is it more efficient, or is it actually accelerated in some way? And so one of the hypotheses that we had was, is there a difference in the phosphoproteome of these muscles? And he did indeed see that some of the glycolytic enzymes that are impacted by the phosphoproteome component seem to be a bit upregulated in those muscles from those steers that had the accelerated tenderization. So it's kind of an exciting track to follow to see where that takes us. I will say we're still kind of in the middle of collecting a lot of that data, but I will say that the metabolomic data does fit the phenotype that we're seeing very well. So we're seeing increases in a lot of the metabolites that one would associate with accelerated pH decline. He's also seen that in those same samples that we're seeing not just an accelerated pH decline, but we're not seeing some of the negative effects that you might think might come along with that.
Mm-hmm.
So that's very interesting to look at. Now, I'm a calpain person,
Mm-hmm.
so one of the enzymes that I look at a lot is the calpain enzyme. So we've asked that question: are the calpains involved in this in some manner? And particularly in those samples from the zinc-fed animals that had the accelerated pH decline, there's an opportunity to say that maybe. But we also think that there's maybe some new things that we can learn, because we're finding some other markers that are popping up that we hadn't looked at before. So it's been really, really fruitful area of study for us to try to figure out, is this a new avenue maybe we could take to look at accelerating tenderness in these cattle, and maybe are there some things that we can learn from looking at the metabolism of these muscles that we could maybe use to manipulate either the way that we process these carcasses, or maybe to manipulate the way that we feed and grow and handle these animals before they actually make it to the market.
In my simple thought process, this sounds like absolute magic, to be honest, because by supplementing with just a little bit, maybe not just a little bit, maybe it's a lot of extra zinc, and we can cover that if you're up for it, but you're getting increased muscle growth potentially, or indeed increased muscle growth, but at the same time improved tenderness, which is sometimes counter to each other as you increase the muscle growth. Oftentimes with growth promoting technologies, we actually have decreased tenderness situation. And talking a little bit about some of the endogenous enzyme path or enzymatic pathways, so the natural enzymes that are in the muscles that are possibly breaking down the muscle tissue, you're thinking those, not just the calpains, but some other pathways may be activated?
Yeah, it's very possible that there may be some other pathways
Wow.
being activated. So think about things like maybe it's impacting the collagen. We don't know. We haven't gone there yet. But, because some of the metalloproteases that degrade collagen, they also do depend somewhat on zinc. So, that's another path to look at with this particular model, to say, is that something that's going on? Maybe are we accelerating some weakening of some of the collagen system? So lots of different things that we need to look at and explore.
Yeah.
But that's a hallmark of good research. I mean, it raises more questions.
More
often.
questions. Yep. Yeah.
We do want to answer some, though.
Right. Yeah, that's just absolutely fascinating. If you don't mind, I'd like to ask what prompted the thought process of the nutritionist to supplement with more zinc?
Okay, well, so Dr. Hansen, Stephanie Hansen, she actually, that's kind of her area of work, is trying to figure out, a lot of the nutritional requirements that were established with very different types of cattle than what we have today.
Yeah.
And so one of the things that she is really keenly interested in learning is, are those nutritional recommendations still valid for these much, much larger and much, much faster growing cattle that we have? And being a mineral and vitamin nutritionist, she's actually keying in on some of these trace elements, if you will, in the diet, and finding that maybe in a lot of cases we're not supplementing to the proper levels. And so zinc was one that she was looking at. She was really interested in its effect on the muscle, and so that's kind of where we came in with that. So
That's amazing.
So I think very frequently we talk about just getting more questions out of research, which is something that we're trying to address, right? One of the things that really kept my attention is the fact that you mentioned the accelerating, trying to get there quickly when it comes to tenderness. So do you think like we can have, let's say, getting to the baseline, the 14-day baseline, that you get the most, well, optimized tenderness by that day? So you think by using zinc, we could get there to 14-day, maybe like at 8 or 10-day, or possibly, or I don't know. That's really, it could change a lot of the supply chain, like if this were to work, right?
Yeah, it'd be really cool, wouldn't it, if it would work? We could do that. And like I said, in our study right now, we're seeing that is happening. So yeah, we need to do it on a larger basis, but we're pretty excited about what we're seeing.
I look at dark cutting, like something like, would that have an impact?
We did not look at dark cutting in this particular study. I don't know. I mean, that's a little bit different mechanism, but certainly would be interesting to see if zinc would have an impact maybe on reducing dark cutters.
Yeah, you mentioned it has a more rapid pH decline. How is that affecting the water holding capacity? Is it purging the muscle out at all?
You know, we saw no difference.
Really?
We looked at purge and saw no difference in purge in those samples. So,
Wow. Well, and for many of the listeners out there, especially the small to medium-sized processors that maybe work with pork at times, I mean, that's one of the big concerns is if we have that rapid pH decline very early on, you can end up with PSC, pale soft exudative pork, and definitely not something we want to see in beef. We don't want it in pork or chicken or anything, but beef is definitely a different muscle too, and so our muscle types setups, and so a fascinating bit of information and rabbit holes we're starting to go down, it seems like, which is really cool. So.
Yeah. No, it's been a fun area to look at. So, and we kind of shared your concern too about PSE, but the accelerated pH decline that we see, it's not quite to the point of hitting that really acidic range yet in the beef muscle, which I think the beef muscle is a little bit more robust too.
I would agree with that. And does it still reach kind of that normal, quote unquote, normal ultimate pH, 5.4, 5.6?
By later times postmortem, there were no differences in ultimate pH in those samples. So just kind of how it got there.
Wow.
Just to put it into context to our folks that may not be familiar with that pH decline, what do you mean that pH decline compared to the control samples? Like, do you recall a little bit about, reaching that ultimate pH at, I don't know, a couple hours before? Or?
So these animals actually did continue a little bit more of a normal pH decline later on. So the early drop in pH that we were seeing occurred between 1 and 6 hours post-mortem.
Okay.
And it never got down to a super low pH. All right, so it was still within the normal range of pH. It just got there faster than the other samples did. And by 7 to 14 days post-mortem, they had pretty much all achieved essentially the same normal ultimate pH. So it was just a more rapid change than what we would had expected to see. So.
And there is, and you can correct me if I'm wrong, but I mean, just subtle changes sometimes in the biochemistry can activate different pathways. Is that right?
Yeah, very much so. Like I said, we've seen that a little bit in our work with the calpains. If you get a drop in pH in that particular protease, the calpain, it's sensitive to changes in its environment. Changes in pH is one of them, and it can actually destabilize it and activate it sooner. So certainly, lots of different things play on that system. You know, when I teach my graduate class and my undergraduate classes, one thing I try to impress upon my students is, at the point of slaughter, it's still, the muscle is still very much an active system. And I tell my students, I mean, meat is not inert stuff. It's still actively metabolizing and working and trying to maintain homeostasis. And the way we handle them, things that we do that impact that tissue, especially in those first hours post-mortem, can have a profound impact on how that muscle tries to maintain some of its very vital processes. So we can really affect it in a lot of ways that we may not even be aware of.
That's a big reminder to all of our processes out there, regardless of size. Remember, we can put 2.5 years worth of time into a beef animal and potentially have some devastating effects in that very short period of time of processing if we're not doing things correctly. So always keep that in mind. We just make sure we do everything the right way, handle the animal appropriately, and then nature will help us out.
Whole system approach.
Yeah.
I just had one follow up on that, and I think we can continue with the next kind of part 2 of this podcast. But are you adding the zinc in the diet, or how many days? Or I guess we didn't talk about that.
Yeah, so it's actually added to the diet, and it is fed. In this particular study, we fed it for the entire finishing period of the cattle. So the cattle came in, started feeding them in August, and were slaughtered in December. They had zinc that entire, super nutritional levels of zinc that entire.
One of the topics that I really wanted to talk about is about the journal, Meat and Muscle Biology. Tell us about your role in the journal. How do you? I think I'm very curious to know more about the behind the scenes, right? We don't get to talk about that very often, but I think this is a good opportunity to talk about what that is and what's the vision and the mission of.
Sure. So, Meat and Muscle Biology. I'm the editor-in-chief of that journal. I've served in that role since June of 2019. Mm-hmm. So the journal is still what I would consider a baby journal, right? So it's a very young, very new journal, very exciting undertaking by the American Meat Science Association. It was started, it had its first issue in 2017. Mm-hmm. So we're on our 5th issue right now. I took over in 2019, and it's been a real growing experience for me, I think, as well as for the journal. So one of the things I was charged with was continuing to increase the awareness of the journal out there, as well as to increase publications and to provide a service to our readers, to our membership, to those in the meat science community. So several things that we've done have been kind of fun. We've expanded the international nature of the journal over the past year and a half. We've added to our editorial board, who kind of helps us oversee the scientific quality of what goes into the journal. And we now have members of our editorial board from 5 continents. So that's a very exciting development. So we're getting very much international representation into the journal, which is very, very, very exciting. We are also working with a private publisher, a very small publisher, Iowa State University Digital Press, who has the mission of promoting open access journals. And so they are very, very committed to seeing associations be able to affordably produce open access journals so that more people have access, if you will, to free access to what's inside of a journal, and it's not behind a paywall. So we were very excited to be able to partner with them also in 2019. And they've been very good to work with and very receptive to a lot of ideas that we've had. One new thing that we've added to the journal is working with a service called Altmetric. And those that have maybe looked at the journal a bit may have noticed this little donut-shaped thing that's appearing on some of the articles. It's a measure of how much attention a particular article is getting in either social media or blog posts, Wikipedia mentions, government documents.
Oh, wow.
So it's another way to look at the impact of a journal article. So it's at the article level. You know, traditionally we think of the impact of an article as how many times it's cited. And that's academics talking to academics. And that's important. We need those metrics. But we also need to know how well is that work getting out into the industry? How well is that work getting into the hands of people that are actually going to be using that? So so many of our articles fit that niche, right? That it's work that's going to be immediately used and applicable by the industry. So this Altmetrics donut, if you will, this Altmetrics score that these articles can receive is a good way for authors to show funding agencies, to show their academic chairs, et cetera, that their work is making an impact in ways other than just being cited by other academics.
Yeah.
And it's a good way for people from outside the academic world too coming in and looking and seeing, how are these articles being used? Because you not only can see the score, right? You can click on that score and you can see who's saying it. So you can read the Twitter mentions. You can go straight to some of the documents that are being used to talk about those articles. So to me, that's really cool, because I get chills when I think about, this is really getting used.
Yeah,
It's exciting
yeah.
to see where it's getting used, because you don't always get to know that.
Well, and that may even lead to more dialogue and more research, possibly, if if it is in the hands of the not just the academic community, but also the industry and government. I mean, there's that really opens up a lot of possibilities of the usage of that knowledge at that point. So, and I'm grateful for the open access, and maybe for the listeners out there who are more in the industry role and don't spend very much time in the scientific journals that are available to us. Open access journals are exactly what it says. It's you can get a hold of that article without having to pay a fee. It's kind of more the author helps with the publication costs versus the readers are paying for the publication costs. But with the intent of making it so it is more available to everyone out there.
Yeah. So the day it's published, it's available to the whole world.
Yeah. Very, very cool. From my understanding, we've just published the 200th article in Meat and Muscle Biology. Is that right?
Yep.
Yeah.
Last week we hit our 200th.
That's awesome.
So that's an important milestone for a journal. So that's good.
Well, and this is, and again, to the listeners out there, if you're not familiar with it, is the journal of, by, and for the American Meat Science Association, but then also to the international community that's beyond America, even though we do have a lot of international members as part of the American Meat Science Association. So really cool to have that as a means of sharing knowledge within our academic community, but then also within the industry with that open access. Can you tell us how you got involved in meat science? How did you get here?
Oh, wow. That's
Yeah.
a long story.
That's all right. We got time.
All right. So growing up, I grew up on a beef cattle farm in northern Missouri, and was always thinking that I was going to be involved with beef cattle and raising beef cattle. Went to the University of Missouri and heard about food science. And I thought, food science. And so I took some food science classes, and I thought, wow, this is kind of cool, because I like to eat, I like to cook, I like beef.
Yeah.
And so I enrolled as a food science undergraduate, did a minor in animal science, did the meats judging team, enjoyed that a ton, as well as livestock judging. And then, but had the opportunity to work in a research lab with Dr. Andrew Clark, and in that same vein was Dr. Harold Hedrick. Dr. Harold Hedrick was kind of one of the icons and wrote quite a few of the textbooks at the time.
Oh, wow.
And Dr. Milton Bailey, who was a food chemist who focused on meats. And I really got to thinking, wow, this is cool, because I liked meat, I liked muscle, because I was thinking about animals growing. I really got into how muscle worked, and was really interested in looking kind of deep into the chemistry of this. I thought, originally I was thinking vet school, and then I thought, well, you know what? I really like this area. It's very, I can help answer some very important questions for the beef industry by following kind of my passion for science. So a bit kind of convoluted, not the path I thought I would take when I was a high school senior.
I'd say that's for a lot of us, in fact.
Yeah. So, but it's been a career that I've been very fortunate to have, and I'm very glad that I ran into those individuals at the University of Missouri as an undergrad.
And then University of Nebraska at some time.
Well, no, my husband went to University of Nebraska.
Sorry, I got the wrong Lonergan mixed
So
up
I did
there.
visit, because we were. So no, I went to Iowa State University then for my master's and my PhD.
Oh, okay, very good.
I worked with Dr. F.C. Parrish, and
Wow.
on the muscle biology side, Dr. Richard Robson, who was a muscle biochemist. And I got my master's and PhD there. Then went to Auburn University, had the opportunity to go down there. It was a for as an assistant professor.
Uh-huh.
It's a fantastic experience,
Yeah.
especially for someone that likes beef.
Yeah, absolutely.
And then I had the opportunity to come back to Iowa State.
Sure. Okay.
So yeah, it's been a fun time.
Yeah.
I'm glad that you asked about her background, because I have one question for you on out of all your research projects, what's been your favorite one and why? If you were to pick one, I'll say
Oh my gosh.
I don't know, something maybe you're not really prepared, but
I would say though, so I've done a lot of pork research in the past, but I would say one of my favorite ones was one I did several years ago. Similar kind of vein, but it was a study where we were trying to figure out, again, tenderness, and we'd been working with vitamin E and its impact on color, right? So we took some cattle and fed them very high levels of vitamin E, trying to think, okay, we're going to impact the color. But being a tenderness nerd, I thought we're going to measure the shear force of those cattle
Yes.
too. Yes. And we found that, lo and behold, those cattle that have been fed vitamin E tended to have more tender product.
Really.
And so we thought, we're going to look at this deeper. And we took another set of cattle and fed them really high levels of vitamin E, so we could get as much vitamin E in that muscle. We then said, okay, we're gonna really stress this muscle and we're gonna irradiate it. So being at Iowa State at the time, we had a linear accelerator, and so we could irradiate it. Creates a lot of oxidation in that product.
Yeah.
We're really gonna stress that system from a color standpoint. And we found out we also stressed it from a tenderness standpoint as well. We essentially arrested tenderness when we did that.
Oh, wow.
But the vitamin E samples seem to have a little bit of an advantage, and so that kind of led us into some of our more seminal studies on the actual function of calpain and calpastatin, some of those drivers of tenderness. And I say it's one of my favorites because it kind of fueled this whole new line of research that we followed, looking at how things like oxidation in muscle can impact the activity of some of these really important proteases, the calpains. How does it affect their activity? And that's something that we needed to look into more. And so we've spent several years, I hate to admit how many years, but so I won't.
That's okay.
Several years following that vein, and have had multiple fruitful studies from that. Looking at how different antioxidant proteins, maybe different antioxidant techniques can actually influence tenderness of products. So it's been fun. And I said that's my favorite one because it kind of led us down that path.
that research that you're talking about, did that had any, like any implications? Some folks in the industry actually wanting to explore more of that?
So that definitely, feeding the high levels of vitamin E definitely has a very positive impact on early color stability. And if the system is stressed in some way, it can also help mitigate some of the tenderness differences that you would see. So it's not quite as consistent as we would always like to see on the tenderness standpoint, but it turns out that it's like a whole systems thing, right? So it depends. If the animal is maybe not as stressed from an oxidative standpoint, not going to have as big of an impact. But if they are in a situation maybe where they are experiencing more stress, it may have an important impact on maintaining tenderness. Certainly color, we know that it does a great job there.
Yeah.
So
Definitely an example of keep an open mind while you're doing research, while you're doing any project for that matter, because you never know what you might stumble upon.
Absolutely. Absolutely.
Fantastic.
Yeah. Well, thank you a lot for joining us today. Well, we
fun.
appreciate your time, and I think we'll keep an eye on this research that you're conducting. And when do you think will be available to the listenership?
Well, we have one article that's actually it's been accepted, so it should be out very, very soon. I would say within the next month or so, it'll be in Meat and Muscle Biology.
Excellent.
Great.
Good to hear.
All right.
All right.
Well, thank you a lot.
Thanks.
Thank you. I enjoyed it.